So in today's lesson, we're going to be looking at how we can determine whether or not a number is prime or composite by using prime factorization. So first thing we're going to do is we're going to take a look at 36 and we're going to ask ourselves, what are the factors of 36? And so traditionally when you guys are looking at factors of 36, you're looking for factor pairs. So I'm looking for the numbers that I multiply together to get to 36. And so some factor pairs that I have for 36 is I have 1 times 36, I have 2 times 18, I'm going to have 3 times 12, 4 times 9, 6 times 6. And then my factor pairs at that point in time would start reversing. So then I would have 9 times 4, I would have 12 times 3, 18 times 2, and then 36 times 1. And when we list out our factors, or looking at our factors of 36, we always list them out in numerical order. So we would do 1, 2, 3, 4, 6, 9, 12, 18, 36. And so this is a skill that you guys have been working on for a while, but today we're going to break this down even further to where I'm going to find, I can identify all the factors of 36 by using what's called prime factorization. And so when we talk about factoring or factorization, so factoring is when I am dividing out, so I'm dividing out a number. When I do prime factorization, we are doing prime factorization is where you factor using only prime numbers. So you get the number broken down into prime numbers. And we talked about in yesterday's lesson that prime numbers only have two factors, 1 and itself. So when I do this with 36, it's going to look a little bit different when I do the prime factorization. So I'm going to take 36 and I'm going to use what's called the ladder method, or in this case, I also like to think of it as upside down division. So I'm going to draw the division box, but I'm going to draw it upside down. And then I'm going to choose a prime factor of 36. So this is where your divisibility rules really become handy to use if you're not sure what are the prime factors. So I know that 2 is a prime number, 3 is a prime number, and they are both factors of 36, so it doesn't matter which one I start with. I do not, however, want to start with the factor 4 because 4 is not a prime number, so 4 is not prime, 6 is not prime, 9 is not prime, 12 is not prime, 18 is not prime, and then it doesn't do me any good to start with 36. So you always want to start with a prime factor. So good numbers to start with are going to be 2, 3, 5, 7, 11, 13, those prime numbers that we worked on in yesterday's lesson. So when we look at the prime factorization of 36, the first value that I'm going to look at is I'm going to choose 2. And I'm going to write it on the outside just like that. And when I do that, what I'm going to do now is I'm going to divide. I'm going to start factoring out 36. So I'm going to divide 36 by 2, and I'm going to write my answer right underneath. So 36 divided by 2 is going to be 18. Now, 18 is not a prime number, so I need to keep going until I have a prime number. So I'm going to divide it out again. And I'm going to look at prime factors now for 18. And so I'm going to keep using 2 because it's an even number. I'm going to go ahead and keep using 2. 18 divided by 2 is going to be 9. So again, you'll notice that as I'm going, I'm kind of just building a ladder with the different rungs. It's getting smaller as I'm finding my factors. Now here, what I'm going to do is I can't do 3 anymore, so I need to find a prime factor of 9, which in this case is going to be 3. And when I divide 9 by 3, I get 3. So I'm now at the point that I have found my prime factorization for the numbers. And so you're going to write this one of 2 ways. The first way that you're going to write it is you're going to write it, well, you're going to write both ways using multiplication symbols, but you're going to write it using multiplication and all of the values. So if I look at my prime factorization for 36, it's going to be 2 times 2 times 2, times 3 times 3. So what I did was I found the values by finding the prime factorization. And what I like about this method versus some of the other methods is that all of my prime numbers, if I do start with a prime and stick with a prime number, all of my prime numbers are going to be on the left side, and then my non-prime factors are going to be on the right side of this method. The other way that you can write your prime factorization is going to be with exponents. So this is prime factorization written without exponents. Notice I still am using multiplication symbol. So it's 2 times 2 times 3 times 3. And then my next step is going to be putting them in exponents. So I look at the factors that I have more than one of. So here I have 2 2's. So it's going to be 2 to the second power times 3 to the second power because I have 2 3's. And so this right here is my prime factorization written in exponent form. So I can actually use all of these factors. I can multiply these out and find all of the factors of 36 except for 1 because 1 is not a prime number. So I have 2 as a factor, I have 3 as a factor. If I multiply 2 times 2, I end up with 4. If I multiply 2 times 3, I end up with 6. If I multiply 3 times 3, I get 9. 2 times 3 times 3 is going to be 12. If I did 3 times 3 is 9 times 2 is going to be 18. And then I end up with, when I multiply all of these out, I end up with 36. So I can use the prime factorization to find all of my factors of a given number, and I can do this generally faster than listing out factor pairs and seeing if I have all of them. A few more just so you guys have some examples. So if I take a look at 75, so again, still using the ladder method, if I take a look at 75, I need to find a prime factor of 75. And so when you look at your divisibility rules, again, the good values that you want to look at are 2, 3, 5, 7, and 11 for your divisibility rules to start. And then you can use other prime numbers up to 100 to find it. So because 75 ends in 5, it's going to be divisible by 5. So my first prime factor that I'm going to use is 5. So I then divide. 75 divided by 5 is going to be 15. Draw my box underneath just to help keep my workspace separate. And then I find a prime factor of 15. Well, it ends in 5, so it's divisible by 5. Divide 15 by 5, and when I divide 15 by 5, I get 3. Now, because I'm at a prime factor here, I'm done. So my prime factorization for 75 is going to be 3 times 5 times 5. Or generally we write prime factorization in exponents form, so it's going to be 3 times 5 to the second power. Okay, let's take a look at another one. So the next one that we're going to take a look at is going to be 20. And so when I look at my prime factorization for 20, I'm going to keep going with 5 because it ends in a 0, so I know it's divisible by 5. 20 divided by 5 is going to be 4. Go ahead and mark that out, and then I'm going to divide 4. I have to find a number that is prime that can divide into 4, which is going to be 2. So 4 divided by 2 is going to be 2. So I now have a prime number down at the bottom. So that means I found my prime factorization for 20. So my prime factorization for 20 is going to be 2 times 2 times 5, or in exponent form, it's 2 to the second power times 5. Okay. Next one that I'm going to do as an example is going to be 52. Okay. So going through and checking, I always like to start with 2 because I can generally find half pretty easily if it's a divisible by 2. And because it's an even number, that means it's divisible by 2. So I start with my prime factor of 2. So 52 divided by 2, half of 52 is going to be 26. I'm going to divide that out. Again, it's an even number, so I can divide it by 2. Half of 26 is going to be 13. Since 13 is a prime number, I've now found my prime factorization. So my prime factorization is going to be 2 to the second power times 13. The first part that we're going to look at, just looking at prime factorization and how to find prime factorization. So you'll be working on a practice where you were working on this skill. But the other piece that we're going to be looking at today is determining whether or not a number is going to be prime or composite. And to do that, we are going to be using the prime factorization to help us, or divisibility rules. So if I start with 66, I can look at 66, and all I have to do to determine whether or not a number is prime or not is I have to find 3 factors. So if I can find 3 numbers that 66 is divisible by, then I know that 66 is not a prime number. Well, 66 is divisible by 2 because it ends in an even number. If I use my divisibility rule for 3, 6 plus 6 is going to be 12. 12 is a multiple of 3. So that right there tells me that 66 is not going to be prime because I now have 1, 2, 3, and 66 as factors. There's a lot more factors for 66, but because I was able to find more than 1 and itself, 66 is not a prime number. This is what we call a composite number. So a composite number is going to have more, so it's going to have greater than 2 factors, whereas a prime number only has 2 factors. It has exactly 2 factors, 1 and itself. Okay, so if we take a look at our next number that we have, we are going to look at 41. And generally, if you go through your divisibility rules and you can't find it, unless it's a value that's a lot larger and a lot larger number, you're probably okay, especially because we have our divisibility rules for the first 12 numbers. So if I take a look at 41, I know that 1 and 41 are my factors. But I'm looking for a number that is prime that I can divide this into. So if I look at this and I go through my divisibility rules, so I'm just going to jot these down. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's not an even number, so it's not divisible by 2. 4 plus 1 is going to be 5, so it's not a multiple of 3 or a multiple of 9. It doesn't end in 0 or 5, so it's not a multiple of 5 or 10. And it's not a multiple of 4. So because it's not a multiple of 2 or 3, that means it's not a multiple of 6. Because it's not a multiple of 3 or 4, that means it's not a multiple of 12. Take a look. 41 is not a factor or not a multiple of 7. It's not a multiple of 8. It's not a multiple of 11. So at this point in time, I'm pretty confident saying that this is going to be a prime number. I could check 13 just to make sure. And so when I take a look at 13, if I do 13 times 3, that gives me 39. So it's not divisible by 13. So 41 is going to be a prime number because it has exactly 2 factors, 1 and itself. You're going to work on your prime factorization practice page or your divisibility quick check. And then when we meet in group, we'll spend some more time working on prime factorization to help you guys build some fluency with how to find the prime factorization of a